Hello everybody, and welcome back to another geometry video. Today we're going to be taking a look at perimeter and area, as well as polygons, our first semblances of shapes. So to start off, we want to talk about what a polygon is. That's going to set us up for the whole rest of this section. A polygon is a closed plane figure, which means it's basically going to be a shape that has an interior and an exterior. So this is an example of a polygon. As long as it has an interior, it's closed up, and it's made of 3 or more straight sides, we're dealing with a polygon here. So a closed figure with 3 plus sides. When we talk about the sides of a polygon, what we mean is we've got these little line segments that go around the outside of the polygon. So this here is a side. The only rule about sides is that they have to be perfectly straight. So line segments that make a polygon is how to define a side. Finally, when we're looking at polygons, every spot where these line segments meet up, the spots these line segments have in common, their intersections, are called vertices, or a vertex. So the vertices are kind of like corners of a polygon. We can write them like this. A vertex is the intersection of 2 sides. Perfect. Anytime we're dealing with a polygon, polygons all have names. So let's take a look down at this table. The name of a polygon is based off of how many sides it has. So we all know that a polygon that has 3 sides, no matter how those 3 sides are drawn, is a triangle, for instance. 4 sides makes it a quadrilateral, 5 sides makes it a pentagon, and again, it doesn't matter how we draw it. So if I draw my pentagon like that, it's got 5 tiny sides. Well, this one's tiny at least. We can go on and talk about hexagons, heptagons, octagons, nonagons, decagons. We skip 11 here to talk about dodecagons, because dodecagons are something that's very, very important. But the list could go on and on forever. Instead of listing off every single type of polygon, if there is a number of sides that we don't have a specific name for, we could just call it an n-gon, where n is the number of sides. So if I wanted to make a polygon that has, 14 sides, we would call it a 14-gon. So n-gon is the general name of a polygon with n sides. And the example I gave was like a 14-gon. Or if you wanted a shape that has 256 sides, it'd be a 256-gon. The thing is, folks, with this list, we are going to have to memorize the polygons in this table. So if I presented you with a shape that looks like this, you would have to be able to tell me what the name of this shape is. How do you do it? Well, again, it's based off the number of sides we have. So if I count out, we have 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides, 7 sides. You'll also notice that this shape has 7 vertices. That's something that is true of polygons as well. They have the same number of sides they do vertices. So this would be a heptagon. In order to classify and name a heptagon, you would call it heptagon, and you would need to present it with a name. All polygons are named based on their vertices. So if I called this vertex A, B, C, D, E, F, and G, this would be heptagon A, B, C, D, E, F, G. With polygons, you must use all the letters that make up the vertices to name them. So I want you to pause the video, and I want you to draw and label at least 5 of these polygons right over here. Pause the video and give it a shot. Hopefully you've had a chance to draw a couple polygons of your own out. When we talk about polygons, we also have 2 more ways that we can classify them. So polygons can also be classified as either convex or concave. Let me draw 2 examples of pentagons here, and we will see the difference between them. There's one pentagon, and there's a second pentagon. Both these have 5 sides, so they're both pentagons. But one of them is convex, and one of them is concave. The easiest way, in my opinion, to identify a concave polygon is if it looks like it has a little caved-in portion, a portion of the polygon that sort of dents in a little bit. Convex polygons don't have any caves. All the points are sticking outwards. So if all your points are sticking outwards, it's convex. If one of your points is sticking inwards, it's concave. But the book definition says it a bit differently, and I want to discuss how we can talk about this. A polygon is concave, we'll start with concave, when a line containing the side of a polygon passes through the interior. If you can take your line segments and turn them from line segments into lines, a concave polygon is when one of those lines passes through the middle a little bit. So this would be concave because I extended this line segment and it's starting to go through the middle of our shape. Meanwhile, a convex polygon, no matter how many lines you draw, no matter how many lines you make of all the line segments, none of them are going to actually go into the middle. The shape is going to stay the exact same. So if I keep drawing these lines all the way around, notice that not a single one has ever touched the center of the shape. That's what it means to be convex. A shape is convex when no line containing the side of a polygon passes through the interior. Cool. Let's flip the page and take a look at some examples. So exercise 1 asks us to classify this polygon by its number of sides. Then we have to decide if the shape is concave or convex. Again, I want you to pause the video and try this one out, but I'll be providing the answers here in just a moment. How'd you do? We've got a convex quadrilateral, a concave hexagon, a concave 14gon, because we don't have a name for a shape that has 14 sides, and a convex octagon. Very nice. We're now going to shift gears a little bit. I want to talk about area and perimeter. This is something that we've talked about in the past, so I'm not going to go too in depth. This is more going to hopefully act as review. So the perimeter of a polygon is equal to the sum of the lengths of its sides. Meaning, if you add together all the lengths of the sides of a shape, you'll get its perimeter. Meanwhile, the area of a shape, or of a polygon, is the amount of space it takes up. We're going to be learning a lot of formulas for area much later, but here are some refreshers that we will need to know for this unit. The perimeter of a triangle is found by adding up all the sides, A plus B plus C. And the area of a triangle is 1/2 the base times the height. The base is whatever side is perpendicular to the height. So they sort of make a T shape. For a square, since all 4 sides are the same, you could do side plus side plus side plus side, or just 4 times the sides. The area is this side times this side, because that would be length times width. But since they're both S, they both have the same length, we could call it S squared. For a rectangle, in a rectangle, the opposite sides are congruent. So we've got L plus W plus L plus W, or 2L plus 2W for the perimeter. The area, meanwhile, is just length times width. So let's take a look at some of these. Let's start by finding the area and perimeter of part A. So one thing I recommend doing with perimeter is I would recommend labeling each of the sides. We know this is a rectangle because of the congruent opposite segments. If this side is 9 feet, then this side is, not G, 9 feet. If the bottom is 22 feet, the top is 22 feet. So when we are finding the perimeter of this shape, all we're doing is 22 plus 22, which is 44, plus 9 plus 9. 9 plus 9 is 18. 44 plus 18 gives us 62 feet. For the area, remember that the area of a rectangle is length times width. So it would just be 22 times 9. 22 times 9 is going to give us 198. But for units, be careful. If our perimeter was in feet, our area is feet times feet, 22 feet times 9 feet. We could write that as feet squared. So since we are multiplying together one unit by another unit, we get that unit squared. Perfect. I want you to pause the video and try B and C, but be very careful with C. I tried to trick you with part of it. Pause the video and give them a shot. Hopefully you've had a chance to give this one a shot. So with B, one of the sides is 6 millimeters, but since all the sides are congruent, we know this is a square. So the perimeter is just 4 times 6, or 24 millimeters. The area, meanwhile, is going to be one of our sides squared. That's what the formula tells us. So 6 times 6, or 6 squared, gives us 36 millimeters squared. Last but not least, we have to find the perimeter area of this triangle. And I tried to trick you on this one. With this triangle, notice that we have two congruent sides. Those two sides are marked off as being the same. So if this side is 8.5 miles, this missing side is also 8.5 miles. The 3.8 does not refer to this side, it refers to the height of the triangle. So if we do 8.5 plus 8.5 plus 15.2, we end up getting a perimeter of 32.2 miles all the way around. The area of a triangle is 1/2 the base times the height. So all we have to do is take 1/2, multiply it by 15.2, which is our base, times that by 3.8, which is our height, and we get 28.88 square miles. These should have been review for us, but if they weren't, please get some practice with them. This is something that we will be doing often. Almost done, folks. The last little bit that we have to talk about here is how to do area and perimeter in a coordinate plane. You are definitely going to want a calculator for this one. So let's take a look at exercise 3. In exercise 3, we are asked to find the perimeter of a triangle named ABC with the vertices here, here, and here. Our first objective should be to plot this on the paper. So let's plot all of these points. To start off, A is at -2, 3, which is right up here. I recommend labeling these points when you put them down. You'll see why later. B is at 3, -3, so that's going to be all the way down here, like so. And C is at -2, -3. So C is going to be right here. Our triangle then is going to look like this. Like so. We are asked to find the perimeter of this shape, which means we need to find the lengths of all 3 sides. 2 of these sides are relatively easy to find the length of. Like, let's look at side BC here, this line segment. We can actually count out how long this side is by counting all the whole numbers it goes through. So it starts at -2, goes through -1, 0, 1, 2, 3. This is 5 squares long. This is going to be 5. Similarly, we can count the vertical length of side AC. 1, 2, 3, 4, 5, 6 squares long. So 6 is the length of side AC. The problem is we do not know how long this last side is. We do not know how long side AB is. This is where we can do one of 2 things. If you know both other sides, you can just do the Pythagorean theorem. But this only works if you know both other sides already. What we'll be seeing a little bit later is sometimes with triangles, you can have many diagonal sides, not just one of them. Like, what if I gave you a triangle that looked like this instead? Boom, boom, boom. It's not a right triangle, so we wouldn't be able to use the Pythagorean theorem. So this is a very limited use, but it makes it a little bit easier. That's why instead, I would like to mention the other way of doing it. To find the length of AB, remember that it's just the distance between points A and B. So we can use our distance formula. As a reminder, folks, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. All we have to do is put in the coordinates of these points. So if we're trying to find distance from A to B, let's put in the x values of these 2 points. We've got -2 and 3, so it's -2 minus 3 squared. The y values are 3 and -3, so it's 3 minus -3 squared. When we simplify this, we end up getting -2 minus 3 is -5 squared. 3 minus -3 is 6 squared. This results in the square root of 25 plus 36, or the square root of 61. In the future, we are going to be reviewing how to simplify square roots. However, what I am going to recommend for right now is convert this into a decimal. Just plug in the square root of 61 into your calculator and round to, usually the nearest hundredth is a good spot to round to. So 7.81. That's the length of AB. Now it's just a matter of putting these together. Since we're trying to find the perimeter here, all we have to do is 6 plus 5 plus 7.81. We find the perimeter of triangle ABC equals 6 plus 5 plus 7.81, which is 18.81 units. There we go. The same can be done when we try to find the area of a shape. So let's take a look at exercise 4. In exercise 4, we're trying to find the area of a triangle that has point D at 1, 3, point E at 4, -3, and point F at -4, -3. And oddly enough, this example is going to be a little bit easier than the last one. Not if I asked you to find the perimeter. If I asked you to find the perimeter here, you would need to find the lengths of these 2 diagonal sides. You'd have to use the distance formula twice. But the area of a triangle is given by 1/2 the base times the height. And we can actually figure out both of these things. In this problem, the base goes from -4 to 4. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 units long. And since this is the base, the height is what goes from D, point D, straight down to our base. How long is that segment? Well, again, it's vertical, so we can count out 1, 2, 3, 4, 5, 6. We have a height of 6. So in that case, the area here is going to be 1/2 of, the base is 8, the height is 6. It's just 1/2 of 8 times 6. If I plug this into a calculator, I will end up getting 24 units squared. Fantastic. All right, folks. The last problem for our notes today is going to be exercise 5. And for this one, I want you to try it on your own. However, I will give my suggestion for how to do this problem in a little bit. So pause the video, give it a shot, and then check your answers. All right. Hopefully you paused the video to give this one a chance. Let's see it together. Point W is at -2, -3. So we got a point right here. X is at 0, 3. So it's all the way up here. Y is at 3, 2. It's going to be all the way over here. And Z is at 1, -4, all the way down here. So our rectangle here is sort of on a slant. It's sort of a slanted rectangle like this. If we're expected to find the area, well, we know that the area of WXYZ is going to be the length times the width. So we'll need to use the distance formula to find both how long it is and how wide it is. Similarly, the perimeter is going to equal 2 times the length plus 2 times the width. So we only have two unknowns here. We need to find the length and the width. I'm going to call this segment our length. I'm going to say that WX is our length. And I'm going to say XY is our width. You could have done this with the other sides instead, but I'm doing it with those two. So to find our length, we need to find the distance between W and X. So we set up our distance formula. The length of this rectangle is given by the formula, the square root of x1 minus x2 squared, so -2 minus 0 squared, plus y1 minus y2 squared. That'll be -3 minus 3 squared. When we start simplifying this down, -2 minus 0 is -2. -2 squared is 4. -3 minus 3 is 6. Or sorry, -6. -6 squared is 36. So we get the square root of 40 for our length. Just because we're doing things in decimals today, I will simplify this down and say that the square root of 40 ends up equaling about 6.32. Again, if you do these in exact radicals, that's even better, but a lot of us don't remember how to simplify those, so that'll be a separate unit or a separate section. Now I need to figure out the length of xy, the width of our rectangle. And it's just a matter of repeating the formula a second time. x1 minus x2, that'll be 0 minus 3 squared, plus y1 minus y2, that'll just be 3 minus 2 squared. 0 minus 3 is -3. Squared gives us 9. 3 minus 2 is 1. Squared is just 1. So we get the square root of 10. The square root of 10 ends up being about 3.16. So to finish off this problem, the area is just the length times the width. It's going to be 6.32 times 3.16, which is going to equal 19.97 units squared, because we're talking about area. The perimeter is going to be 2 times the length, so 2 times 6.32, plus 2 times the width, which is 3.16. When we plug that into our calculator, we should end up getting 18.96 units. So there we go. That's how we do exercise 5. Thank you so much, everybody. This will conclude our notes for today. Have a fantastic rest of your day.